midterm presentation of the semester case of the core systems designing and engineering. We are TeamAlpha. We are 11 engineering students from 3 disciplines: mechanical, electrical and software. We as a team have been given the task to design a product. It can be a very good way to see things from a different perspective and allow us to come up with many different ideas. Even though there are some challenges associated with having people with different disciplines in the same group, it is still very important, as it will prepare us for working with these kinds of groups later in life. Our concept. Our mission is to develop an unmanned ground vehicle to transport supplies to people in need in a hostile region and gather information about the area. We have a time limit to deliver supplies within 48 hours. We have limited information about the situation in the area, but what we know is that the enemy have fled the scene or surrendered, but have been highly active with placing anti-personnel mines, destroying roads, building roadblocks and blowing up bridges. However, there is always a chance that angry fanatic warriors are still present. The landscape is dominated by sand, a lot of rubble in our path and desperate people in need. This is why we chose to design an unmanned ground vehicle that is autonomous, with the capability to be manually controlled by an operator in certain conditions. The UGV can deliver the supplies by itself or with some assistance. This is a much better alternative than sending a human, whose life would be in danger in such hostile environments. Usually this type of vehicles will have a set of sensors to perceive the environment, cleaning system for the same sensors, and will either autonomously make decisions about its behavior or pass the information to a human operator at a different location. This operator will control the vehicle through teleoperation and have a live image to retrieve the information needed for controlling. There are some risks by steering the vehicle by satellite or teleoperation because of time delays of the signals that we receive. If this is the case, the vehicle can be too dangerous for the environment and can either collide with some obstacles, fall in a hole, drive off a cliff or even hit some civilians. Therefore we chose a LiDAR system as a primary organ of the vehicle, with which we can perceive the environment. The concept of the vehicle that we first thought about was a kind of truck which could carry a lot of cargo, approximately 10 tons. We thought that it would be a great way to help many people at the same time, but we didn't consider the economic loss if one of these trucks were destroyed or lost. Later we found that by using a pug matrix that it would be more beneficial to have a smaller vehicle such as an Arctic truck. The Arctic truck have a higher average score than the vehicles we compared it with. Although it has a lower capacity, the economic loss would not be as great if it's lost. A smaller vehicle is also more agile and can more easily navigate through terrain and urban environments, and will not be as threatening to the inhabitants. Our first truck can also be mistaken for military traffic, not only in looks, also the sound from its V8 diesel engine. The key performance parameters. The key performance parameters are specifications that are critical performance goals of our UGV. Our KPP are results of the conditions where the UGV is operating: bad roads, difficult terrain, obstacles and so on. Because of these rugged roads and off-road terrain, we have calculated that the average speed of our vehicle will be approximately 40 km an hour. In ideal conditions, the vehicle will reach top speed of at least 80. The cargo is estimated for 100 persons for 3 days and will have a weight of at least 2 tons and a volume of 3 cubits. The estimated distance from evaluating maps and listening to intelligence from this specific area is about 160 kilometers. With all uncertainties, the total range of operation is 700 kilometers. The delay of the one-way communication should not exceed 1 second. Since we are working in a crisis area, we want to use as little time as possible to deploy our vehicle. We have estimated an optimal deployment time of 30 minutes, which includes loading from airplane, filling cargo, and setting up the data for transport. The life cycle stakeholders. Our potential life cycle stakeholders are divided into groups: production, usage, service, and recycle. The most important stakeholders stakeholders are engineers and developers, and then comes the customers. Some other important stakeholders are maintainers, producers of the parts, government and military. Each of these stakeholders have their own concern related to this project, and sometimes these concerns can either overlap or come in conflict with each other. Customers' concern would be price and quality of the product, and developers' concern with how to balance the cost and have a good quality. Some concerns which the government might have is the safety of its people and the humanitarian workers. Some questions kept repeating itself. While working with the project, some questions were triggered, and the most discussed problems were if the vehicle should be autonomous or semi-autonomous, how we should communicate with the vehicle, the area of operation, what capacity is required, weight and volume, the price range, which type of materials should be used in production, and how to connect the electronic parts to the car together. Our group dynamic. We have get to know each other better, and we all have experience from our respective disciplines that can contribute to improve the project in a positive, good way. In some difficult days we have been very supported and motivated of each other and by our supervisors, but there is always a tendency to lose our target and discuss other not relevant problems. The tasks have been given in a fair manner, which made it much easier to work as a group, since everyone had a clear role. Something we can improve is to be more effective and purposeful during the meetings, and in the end arrange more meetings. Work schedule. Our further work schedule is to go more in depth to design more advanced technical and functional model, and even begin to draw a 3D model prototype of our UGV. We are going to be more specific with which models we are going to use, and a plan to begin with a Gantt diagram. Thank you.